MEI Statistics Minor, Bivariate Data 3, Lines of Regression. 3.4 Regression line of y on x for random on random data. So a regression line is inappropriate if there is any evidence of a nonlinear relationship. So here a regression line would be clearly inappropriate because there's quite a clear curve to the data. Here, though it is a cloud, there is evidence of a linear relationship going through the middle there, so that would be appropriate. So here we have a data set showing the height and mass of male Year 13 students. Remember, there is no control variable, this is random on random data. The regression line calculation would run through there. And if you're asked a similar question to the ones asked in the random on non-random data, estimate the mass of a male student with height 1.65 meters. Well, if we look at 1.65 meters and we were asked to estimate the mass of those students, it's a rather nonsensical question. The mass of those students could be anywhere from up here to down here. There could even be possibilities outside. With no further information, we would have no way of estimating the mass of a single male student. There's such a range of values that we simply can't answer this question. What the regression line shows in this case is the mean value of the masses of people with heights 1.65 meters. So if we draw a rough ellipse around the data, this data is showing a bivariate normal distribution, which is in a roughly elliptical shape. If we have a look at the height for 1.5 meters, you can see that the mean is going to be roughly around there. For 1.7, the mean is roughly going to be in here, and the mean at 1.9, the mean is roughly going to be up here, and so that's where the regression line goes through. So the regression line of y on x estimates the mean of y for a given value of x. The process of calculating this line of regression is exactly the same as for random on non-random data. If we have a sample of students with their height and mass recorded, and we're asked to calculate the equation of the regression line of mass on height, that means we want to make our mass the y and our height the x. Pop that in our calculator, the stats function on the calculator, check your calculator manual for how to do that. Alternatively, you may be asked to work it out with summary statistics. Find the least squared regression line of m on h. So in the formula book, remember we have these equations, but then we also have one more equation underneath. So the least squared regression line of y on x is above. The least squares regression line of x on y is below. So for random on random, it doesn't actually matter which is x and which is y. You just pick between the two, whichever one you need. I'm going to use x equals h and y equals m. So I'm going to be using the first formula here. So I'm going to write x equals h, y equals m somewhere so I don't forget. I'm going to find SHH. I'm going to find SHM, I'm going to find B, I'm going to sub it into my equation, and then I'm going to rearrange to get M equals 0.903 plus 40.7 H to 3 significant figures. The process is exactly the same as the last video. So, if I'm asked to estimate the mass of a male student with height 1.65 meters, it's the wrong question. The correct question would be estimate the mean mass of male students with height 1.65 meters. And so for this we would simply sub in h equals 1.65 in our calculator. In the next video we're going to be looking at the regression line of x on y for random on random data.